So, good morning everyone. Today we are going to discuss about the second year important chapter Electrochemistry. Electrochemistry, this is the most important chapter for objective Electrochemistry. Important chapter Electrochemistry. So, the branch explain which deals with the branch deals with the conversion of electric energy into chemical energy. So by the passage of electric current, we are generating new chemical substances, conversion of electric energy into chemical energy. That is nothing but electrolytic cell. Electrolytic cell. Electrolytic cell. Conversion of chemical energy into So by using spontaneous redox reaction, we are generating electric energy. That is nothing but electrochemical cells. Electrochemical cells. So cells, electrochemical cell. The branch of physical chemistry which deals with the study about conversion of electric energy into chemical energy or chemical energy into electric energy. Electric energy converted into chemical energy is nothing but electrolytic cell. Chemical energy converted into electric energy is nothing but electrochemical cell. Now, what is meant by conductor? The substance which has a tendency to pass electric current. The substance which has a tendency to pass electric current through itself, either in molten state or in aqueous state, is nothing but conductor. The substance which has a tendency, which has a capability, which has the ability to pass electric current, through itself, either in fused state or in aqueous state, is nothing but conductor. Non-conductor or insulator. Non-conductor or insulator. Non-conductor or insulator. The substance which has no capability, unable to pass electric current. Unable to pass electric current. Unable to pass electric current through itself, through themselves, is nothing but insulator, glass, stone, wood are examples of, dry wood are examples of insulator or non-conductor. So there are two words. One is a conductor, next one is a insulator. Conductor means the substance which has a tendency to pass electric current. The substance which has a tendency to pass electric current. Through itself. Through itself is nothing but conductor. Which one unable to pass? Which one unable to pass electric current is nothing but insulator. Which one unable to pass electric current is nothing but insulator. Okay. Now, conductors are mainly two types. Conductors are mainly two types. One is electronic conductor, electronic or metallic conductor. Second one is electrolytic conductor. Electrolytic conductor, it is also called as electrolyte. Electrolytes. So conductors are mainly two types. One is electronic or metallic conductor. Second one is electrolytic or electrolytes. Electrolytic conductors. Conductors are mainly two types. One is a electronic conductor, second one is a electrolytic conductor. Now, electronic conductor, or it is also called metallic conductor. Next one is electrolytic conductors. Electronic or metallic conductors. The conductivity is due to mobility of electrons, the free movement of electrons, mobility of electron. The substance which has a tendency to pass electric current, the chemical species, the substance which has a tendency to pass electric current, due to the mobility of electrons, due to the free movement of electrons. Mobility or free movement of electrons is nothing but electronic or metallic conductors. Electronic or metallic conductors. What are electrolytic conductors? Electrolytic conductors. Conductivity is due to the mobility of ions, oppositely charged, free mobility of free ions, either in aqueous state or are in molten state or fused state. Molten state. The substance which has a tendency to pass electric current, the substance which has a tendency to pass electric current due to the mobility, due to the free movement of ions, either in aqueous state or in molten state. Molten state is nothing but electrolytic conductors. The substance which has a tendency to pass electric current due to the mobility of electrons is nothing but electronic or metallic conductors. No chemical reaction takes place. No chemical reaction takes place. A redox reaction takes place. Spontaneous oxidation, redox reaction takes place. Chemical reaction takes place. At electrodes, at anode and cathode, at electrodes. New chemical substances are obtained at anode and cathode because of oxidation reduction, redox reaction. No mass transfer takes place. No mass transfer takes place. No mass transfer takes place. Here mass transfer takes place. New chemical substances are obtained. New chemical species are obtained. New chemical species are obtained. New chemical species are obtained. Mass transfer takes place. Temperature increases. Vibrations increases. Temperature increases. Vibrations increases. Resistance increases. Conductance decreases. Conductance decreases. As temperature increases, vibrations of charged particles increases. Vibrations increases. Resistance increases. Resistance is the opposition to the flow of electric current. So resistance increases, conductance decreases. Here, temperature increases, degree of ionization, dissociation of electrons increases, degree of dissociation increases, mobility of free movement of ions increases, hence conductance increases. So temperature directly proportional to conductance. Temperature directly proportional to conductance. Temperature inversely proportional to conductance. So in electronic or metallic conductors, the conductance is due to the mobility of electrons. Electrons flow from negative end to positive end. Mobility of electrons. Conductivity is due to the mobility of ions either in aqueous or maybe molten state. No mass transfer takes place. Mass transfer takes place. New chemical substances are obtained at anode and cathode. No chemical reaction. Redox reaction takes place. Oxidation takes place at anode and reduction takes place at cathode. As temperature increases, resistance increases, conductance decreases. Temperature increases, degree of ionization increases. As degree of ionization increases, more number of ions available for the free movement increases. Hence, conductance increases. Now, what is meant by electrolyte? What is meant by electrolysis? Electrolyte. Electrolyte means electrolyte, the substance which has a tendency to pass electric current. The substance which has a tendency to pass electric current. To pass electric current the substance which has a tendency to pass electric current. The substance which has a tendency to pass electric current either in through itself, either in aqueous state or are in molten state. Molten state is nothing but electrolyte. The chemical species, the substance which has a tendency, which has the ability to pass electric current, through themselves, either in aqueous state or in molten state, but not solid state. In solids, the free movement of ions are not possible because these oppositely charged ions are attracted together by strong electrostatic force of attraction. So in solid state, there is no mobility of ions. Hence, in solid state, they are bad conductors. But the substance which has a tendency to pass electric current either in fused state or in aqueous state due to the mobility of ions towards oppositely charged electrodes. Hence, they act as a electrolyte. Electrolyte is two types. One is a strong electrolyte. Second one is a weak electrolyte. Strong electrolyte means the substance undergo complete ionization, complete dissociation or ionization, and has it greater the tendency to pass electric current. The substance undergo complete ionization and has a greater tendency to pass electric current is nothing but a strong electrolyte. Examples: strong acids like HCl, Hi, HNO3, H2SO4, etc. Strong bases like NaOH, KOH, etc. Salts of strong salts like NaCl, Na2SO4, K2SO4, etc. Graphite metals, all the metals, graphite act as electronic or metallic conductors. Due to the crystal defect, copper sulfide, cadmium sulfide, metals, graphite are good conductors. They are good metallic or electronic conductors. That is the main difference between metallic as well as electrolyte. So strong electrolyte, the substance which undergo complete ionization and it has a greater tendency to pass electric current through itself is nothing but strong electrolyte. Weak electrolyte, the substance undergo partial ionization. Partial ionization. The substance which undergo partial ionization, do not undergo complete ionization. The substance undergo partial ionization, which has a lesser tendency to pass electric current, which has a lesser tendency to pass electric current, through itself is nothing but weak electrolytes, weak acids, weak bases are examples of weak electrolytes, weak acids, HCN, H2S, CH3COOH, etc. Weak bases, aluminum hydroxide, ammonium hydroxide, zinc hydroxide, etc. All the weak acids and weak bases are examples of weak electrolytes. This is the difference between strong and weak. Generally, the factors which are influenced by the electrolytic conductors, nature of electrolyte, that is strong or maybe weak. Concentration inversely proportional to conductance. As concentration increases, attraction, number of ions per unit volume increases. Attraction between the charged particles, ions increases. Attraction between the opposite charged ions increases. As that the force of attraction increases, mobility of ions decreases. As the mobility of ions decreases, conductance decreases. So conductance inversely proportional to concentration. As temperature increases, degree of ionization increases or dissociation increases. As the degree of dissociation increases, mobility of ions increases, therefore conductance increases. This is about electrolyte. So in this class we discuss what is meant by electrochemistry, what is meant by conductor, what is meant by insulator, and the types of conductors and types of electrolytes. Now we are going to discuss about what is meant by electrolysis. Electrolysis. The phenomena of the process of decomposition of a substance, chemical decomposition of a substance by the passage of electric current, Electrolysis, the process of chemical decomposition of a substance, by the passage of electric current, and spontaneous redox reaction takes place. Redox means both oxidation and reduction takes place at electrodes. New chemical substances are released or deposited. New chemical species are deposited or liberated at electrodes. The phenomena is nothing but electrolysis. The process, the phenomena of chemical decomposition of a substance by the passage of electric current through electrolyte and a spontaneous redox reaction. Both oxidation and reduction takes place at electrodes, at anode and cathode, and new chemical substances are deposited or liberated at electrodes. The phenomena is nothing but electrolysis. The device which is used to carry out electrolysis is nothing but electrolytic cell. Electrolytic cell. The device where electrolysis is carried out is nothing but electrolytic cell. Electrolytic cell. The cell consists of two electrodes, two rods, two electrodes. One is anode, next one is a cathode. Anode. The sign of anode is a positive and the sign of cathode is a negative. The sign of cathode is a negative. These both are connected through a battery, and the cell consists of electrolyte. So there are two different words. One is electrolytic cell, next one is electrolyte. Suppose this is a molten NaCl. What is meant by electrolyte? The substance which has a tendency to pass electric current through itself is nothing but electrolyte, either in molten state or in aqueous state. The device from the cell, the device or the apparatus where electrolysis is carried out is nothing but electrolytic cell. The electrolytic cell consists of two rods. One is anode, next one is a cathode. Listen carefully, most important topic, anode and cathode. The sign of anode is positive and the sign of cathode is negative. The cell is filled with the electrolyte. Here molten NaCl is taken as electrolyte. On passing electric current, NaCl decomposes to form Na plus Cl minus. It consists of Na plus and Cl minus. Cl minus ions, Na plus ions. 2 NaCl gives rise to Na plus 2 Cl minus. All the Cl minus ions move towards oppositely charged electrode, means anode. At anode, always what type of reaction takes place? At anode, always, remember, at anode, always oxidation takes place. Oxidation means loss of electrons, de-electronation, removal of electron. So, all the Cl minus move towards anode, oxidation takes place. Chlorine gas is liberated. So these electrons move towards a cathode. At cathode, what happens? All the Na plus ions move towards a cathode. These Na plus ions takes up electrons coming from the anode undergo reduction. Sodium metal is deposited. This is electronation or a reduction. So oxidation takes place at anode and reduction takes place at cathode. This is nothing but electrolysis. Electrolysis means the process of chemical decomposition of a substance, that is electrolyte, by the passage of electric current through itself and undergoes spontaneous redox reaction. Both oxidation reaction takes place and new chemical substances or species are deposited or liberated at anode or maybe cathode. Anode or maybe cathode. The phenomenon is nothing but electrolysis. The sign of anode is positive, the sign of cathode is negative. All the negative charged particles are moved towards anode and all the positive charged particles are moved towards cathode. Undergo oxidation at anode. Everyone should remember, at anode always oxidation takes place, at cathode always reduction takes place. Oxidation means loss of electrons or de-electronation. These electrons are moved towards a cathode, undergo reduction. Reduction means gaining of electrons or maybe addition of electrons, electronation. Okay. Electrodes are two types. One is inert electrode. These are chemically inactive. Do not participate in, do not involve in. Do not involve in, do not participate in electrolysis. Electrolysis. Do not participate in electrolysis. Example, platinum. Active electrode. The electrodes are participating in electrolysis. They undergo some chemical change. Itself they undergo chemical change. Itself it is participating oxidation reaction. Means chemical reaction. Electrolysis. Involve in electrolysis. Involve in electrolysis itself. Example, copper, silver, nickel, etc. So electrodes are two types. One is inert, next one is active. Inert electrodes. The substance, that means the electrodes which do not participate in electrolysis. They do not undergo any chemical change. These are chemically inactive. Active means they undergo itself, they participate in electrolysis. Electrolysis. They undergo chemical change. Is nothing but active electrode. And one more thing. Suppose the given electrolyte consists of, two or more cations, positive ions, or are anions, two or more cations or maybe two or more anions. Which cation or which anion move towards the oppositely charged electrode? Which anion move towards the anode first? Which cation move towards the cathode first? Depends upon the preferential adsorption. Or depends upon the adsorption potential. The cation or the anion which requires lesser the discharge potential, more will be the deposition. At electrodes. Among lithium and sodium, discharge potential of lithium is more, hence which deposited lesser extent when compared with the sodium. Among sodium and hydrogen, discharge potential of sodium is more, hence which is having lesser the deposition when compared with the hydrogen. So the given electrolyte consists of two or more cations or two or more anions. Which cation or which anion may move towards cathode or anode depends upon their discharge potential. The species with lesser the discharge potential, more will be the deposition. More will be the deposition. So everyone should remember F minus, NO3 minus, SO4 minus 2. Generally, they do not undergo oxidation at anode because they possess higher the discharge potential. Due to higher the discharge potential, they never undergo oxidation at anode. Oxidation at anode. Okay. So, for example, what are the chemical reaction takes place by using aqueous NaCl? Aqueous NaCl consists of Na plus ion, Cl minus ion, H plus ion, OH minus ion. Order of discharge potential, F minus more than NO3 minus like this, SO4 minus 2. Next, OH minus less than, Cl minus, Br minus less than, which is discharge potential. So the discharge potential of OH minus is more when compared with the Cl minus. Actually, what happens here? NaCl decomposes to form Na plus plus Cl minus. But aqueous NaCl consists of OH minus and Cl minus. There are two anions. Which anion move towards anode? Either Cl minus or maybe OH minus, depends upon the discharge potential. Discharge potential of OH minus is more when compared with the Cl minus. Hence, Cl minus are move towards anode easily when compared with the OH minus. Therefore, the Cl minus ions move towards oxidation. Chlorine gas is liberated by the loss of electrons. Chlorine gas is liberated by the loss of electrons. So all these Cl minus ions move towards anode. All these Cl minus ions move towards anode and chlorine gas liberated. Similarly, cathode. Actually, H2O. Wait a minute. H2O gives rise to H plus plus OH minus. The discharge potential of H plus is lesser when compared with the Na plus. Hence, all the H plus ions move towards anode under reduction. Hydrogen gas is liberated. So, electrolysis of aqueous NaCl, hydrogen gas liberated at cathode, chlorine gas liberated at anode. The resultant solution consists of Na plus and OH minus ions. These both are combining with each other. And forms NaOH. The resultant solution is a basic in nature, alkaline or basic in nature, and pH greater than 7. So aqueous NaCl consists of Na plus, Cl minus, H plus and OH minus ions. Then you have to observe the discharge potential of OH minus is more when compared with the Cl minus. Hence, the Cl minus ions move towards anode, undergo oxidation, chlorine gas liberated at anode. Okay, ma? Chlorine gas liberated at anode. At cathode, among Na plus and H plus, discharge potential of H plus is lesser when compared with Na plus. So, these H plus ions move towards cathode, undergo reduction. and hydrogen gas is liberated. So electrolysis of aqueous NaCl, hydrogen gas liberated cathode instead of sodium, chlorine liberated instead of oxygen at anode. The resultant solution consists of Na plus and OH minus. These both are combining with each other. There is a formation of sodium hydroxide. So these are alkaline in nature and pH more than 7. Okay. Here, electrolyte. Aqueous copper sulfate. Anode, platinum. Cathode, platinum. So CuSO4 decomposes to form Cu plus 2 plus SO4 minus 2. Actually, aqueous copper sulfate consists of Cu plus 2 ions, sulfate ions, H plus ions and OH minus ions. Okay. At anode, the OH minus ions move towards anode. Oxygen gas is liberated. Oxygen gas is liberated at cathode. The discharge potential of cathode is lesser when compared with H plus. Hence, Cu plus 2 by takes up 2 electron, copper is deposited. So by using platinum electrode, platinum cathode and platinum anode, on passing electrolytic, on passing electric current through aqueous copper sulfate solution, oxygen gas liberated at anode and copper is deposited at cathode. Electrolyte, aqueous copper sulfate solution. Anode, copper. Here anode is platinum. Here anode is copper. Cathode, platinum. Okay. So, copper is active electrode. Itself undergo oxidation. So, what type of reaction takes place at anode? At anode, what type of reaction takes place? At anode, copper itself oxidized. Cu gives rise. Cu plus 2 by the loss of 2 electrons. Copper itself oxidized. You have to observe the reaction takes place at anode by using same electrolyte, by using same aqueous copper sulfate, by using different electrodes. Here anode is a copper, here anode is a platinum. If it is platinum, oxygen gas is liberated. If anode is copper, copper is oxidized itself. Copper itself, it is a participate in electrolysis. Cu gives rise Cu plus 2 by the loss of 2 electron. At cathode, what happens? What type of reaction takes place? Cu plus 2 electron gives rise Cu. So, aqueous copper sulfate solution is taken as electron and passing electric current through aqueous copper sulfate solution by using copper anode. At anode, copper is dissolved. At cathode, copper is deposited. No change in the concentration of copper. These are the chemical reaction takes place during the electrolysis at anode and cathode. So remember everyone, these are the most important points. Point number 1, F minus or NO3 minus or SO4 minus. So electrolysis of aqueous alkali metal sulfate or electrolysis of sulfate or maybe nitrate or maybe fluoride. So either maybe sulfates or maybe nitrates. Oxygen gas is liberated at anode. Oxygen gas is liberated at anode. If electrode is active, itself undergo oxidation. So among the two electrolyte consists of 2 or more cations or maybe 2 or more anions. Which cation or which anion may require lesser the discharge potential? They deposit or liberated electrodes more easily. Lesser the discharge potential, more will be the deposition or liberation at electrodes. So now we are going to discuss about a few problems based on the electrolysis concept. So when copper sulfate solution is electrolyzed, substance formed at anode. Just to be discussed. Copper sulfate solution contains Cu plus 2 ions, He plus ions, SO4 minus 2 ions and OH minus ion. Is asking, when copper sulfate solution is electrolyte, substance formed at anode but not cathode. Remember, but not cathode, anode. At anode, the sign of anode is positive. At anode, oxidation takes place. So all the negative ions, all the anions move towards anode. But it consists of 2 anions. Which anion move towards anode depends upon the discharge potential. And already we discussed, sulfate ions never move towards, never undergo oxidation. Then OH minus ions move towards anode. Oxygen gas is liberated. Okay. Then the option is 3. Suppose at cathode, what type of reaction takes place and which one is deposited? So among Cu plus 2 and He plus, the discharge potential of H plus is more when compared with the Cu plus 2. Therefore, all the Cu plus 2 move towards cathode. Copper is deposited. So copper is deposited at cathode and oxygen is liberated at anode by the electrolysis of copper sulfate solution. Here the answer is the third option. Option 3.